American explorer Victor Vescovo descended nearly 11 kilometers into the Mariana Trench, and this, at its lowest point, is nearly 11 kilometers deep.
The Mariana Trench is the deepest place on Earth. It is found in the Pacific Ocean and goes down 7 miles. The Earth, which is 4.5 billion years old, keeps changing and surprising us. Continents move, volcanoes explode, and glaciers grow and melt, creating amazing landscapes. What hidden truths does this deep, dark place hold? Join us to find out more about the fascinating details of the Mariana Trench and what lies beneath the ocean, uncovering the ocean's hidden depths. Exploring the Mariana Trench is like diving into the deepest parts of our planet's oceans. This place is not just deep, it's fascinatingly complex, with scientists facing extreme challenges as they descend into these dark waters. They're like detectives, trying to figure out what powerful natural forces have shaped this underwater world. Down there, they found incredible sights like erupting underwater mountains, strange mud volcanoes, and the Earth's largest geological feature. The things they learned from this unique underwater area could really change our understanding of how the Earth itself is formed and reshaped over time.
An amazing dive. I think almost exactly 12 hours.
Tucked away in the Western Pacific, the Mariana Trench is the deepest spot in all the world's oceans. The quest to understand how this deep scar in the Earth's crust came to be and how it keeps affecting our planet started way back in 1872. That's when a British ship, the HMS Challenger, embarked on a groundbreaking mission to map the ocean floor. Before this, people thought that once you went deep enough, the ocean was just a flat, boring, lifeless place. They really didn't expect to find anything interesting. The Challenger and its crew spent 4 years sailing about 70,000 miles. That's nearly a third of the way to the moon. Every 140 miles, they would measure the depth using a massive amount of rope, 249 miles of it, and lots of lead weights. It was tough, grueling work. But back then, that was the only way to figure out how deep the ocean was.
Nobody thought the ocean was this deep. So all of a sudden we've got scientists saying, why is that?
When they reached a spot in the Western Pacific, 200 miles from the island of Guam, they kept lowering their measuring rope, expecting it to hit the bottom soon. But to their surprise, it just kept going and going. It was a huge shock. No one had thought the ocean could be this deep. When the weight finally hit the bottom at 4,475 fathoms, nearly 5 miles down, it opened up a ton of questions. What had they found? Was it a small dip, a huge hole, or something else? Finding this spot made everyone really curious about what else was down there. This trip by the Challenger is considered the start of modern oceanography. It gave us the first rough map of the ocean floor, showing how it slopes away from the land and then drops off into vast flat plains. But the Western Pacific was different. Here, the floor takes a sudden dive into a 5-mile deep trench, completely upending the old idea that the ocean floor was flat and uneventful. It would be another 75 years before we'd start to get some answers. That's when a new gadget called sonar came into play, taking our exploration to a whole new level. Sonar started as a way to find submarines during the early 1900s and got really good by the 1940s. It works by sending out sound waves underwater. These waves bounce off things and come back. And by timing these echoes, scientists can get a clear picture of what's beneath the surface. Using sonar turned out to be a lot easier and cheaper than having a bunch of sailors pull on ropes.
The world's major navies spend a lot of time and effort developing submarine hunting technology.
In 1951, a British naval ship with this fancy new sonar gear went back to that deep spot the Challenger had found. The results were amazing. They made detailed maps with sonar and discovered that what they thought was a hole was actually part of a massive trench, 30 times deeper than the Empire State Building is tall. This trench stretches over 1,500 miles, about twice the length of California, from southeast of Guam to northwest of the Mariana Islands. People were probably amazed by what they saw. The ocean floor wasn't just flat. It was full of mountains and valleys. To a geologist, this was super exciting. The trench itself had so many differences. At its southern end, it drops down another 2 miles to its lowest point, a mind-blowing 7 miles below the ocean's surface. Scientists have found the deepest spot in the ocean, which is still the lowest known point on Earth today. They named this deep spot the Challenger Deep, in honor of the ship that first discovered it. To really grasp how deep this part of the trench is, imagine if you placed Mount Everest down there. You'd still have about a mile of water above you before you even start to see the surface of the ocean. However, how exactly the Mariana Trench came to be was unclear. Researchers figured the best way to learn more was to go down and check out the Challenger Deep themselves. But this wasn't going to be easy. At the bottom of the trench, the pressure is so immense, it's like having the weight of 50 large airplanes pressing down on you from every side. Next, we explore a historic and daring mission that marked a milestone in underwater exploration. Extreme pressure of the deep sea. To show what this kind of pressure does, scientists did a test with a styrofoam head. They're planning to put one of these heads, which are usually used for displaying wigs, into a pressure chamber to simulate the deep ocean conditions of the Mariana Trench. This is about 16,000 pounds per square inch.
Wow, that's smaller. And here's what the original size was, just for comparison.
If it were a real human head, it would be totally crushed. Instead, the styrofoam head compresses, shrinking significantly. It's quite a sight. To give you an idea, they compare it to the original size, and it's a huge difference. It really shows how extreme the pressure is down there, and it's a good thing humans aren't subjected to that environment. Protecting humans from such extreme conditions posed a real challenge to the engineers. Back in 1953, a Swiss scientist named Auguste Piccard designed the Trieste, a deep-sea submersible capable of withstanding those crushing depths. The Trieste had a long, 50-foot hull filled with light aviation gasoline and lead weights to help it stay balanced underwater. Beneath this, there was a small, round cabin, just 6 feet across, with thick steel walls, designed to keep the intense pressure out. After 7 years of tweaking and testing, including several manned dives that went no deeper than 3.5 miles, the Trieste was finally ready to make the full 7-mile descent to the bottom of the trench. The man in charge of this daring feat was a U.S. Navy lieutenant named Don Walsh, an experienced deep-sea explorer. This mission was kept under wraps because only a few top officials knew about it. It kicked off in January 1960 from the island of Guam, which was pretty isolated back then, just the right spot for a low-key but risky project like this, as the Navy really didn't want any public embarrassment if things didn't go as planned. Accompanying Walsh on this historic descent was Jacques Piccard, the son of the Trieste designer. The two of them were crammed into a tiny, cold sphere, not much bigger inside than a large household fridge, for about 9 hours. They were setting off to explore one of the most remote and tough places on the planet, the Mariana Trench. Their slow descent into the deep began at a pace of just 3 miles per hour. As they went deeper, around 3,000 feet down, they were enveloped in complete darkness, the sun's light unable to reach them. The only sources of light were the Trieste's powerful lamps, and occasionally flashes of light from sea creatures that produced their own glow, like underwater fireflies. This trip was more than a technical challenge. It was an epic plunge into one of Earth's final frontiers. Inside their solid steel sphere, Walsh and Piccard sailed past their previous deepest dive of 18,000 feet without a hitch. It seemed everything was going according to plan. They were well protected at the back of their cabin by 2 layers of glass. But around 2 hours into their dive, a sudden loud bang startled them. The outer glass layer had just cracked. Now they were around 20,000 feet underwater and quickly checking over their gear in the cabin. Their small capsule, designed to support life under extreme conditions, was now under even more stress, facing a massive 8 tons of pressure per square inch. With the outer glass gone, only 1 layer stood between them and a fatal ocean crush. The situation was critical. A breach in the inner glass would mean immediate death. Miraculously, it held, and the two decided to brave the depths further as they continued their descent for almost 5 more hours. Tense and alert in the cramped space of their cabin, they neared the very bottom of the trench. Just when they thought they'd seen it all, something moved on the ocean floor, a flatfish, about a foot long. Seeing a fish at this incredible depth was unexpected and fascinating. It confirmed they had reached their destination, the lowest part of the Mariana Trench. The depth gauge read 35,800 feet, nearly 7 miles beneath the sea's surface, aligning perfectly with the sonar data. Now, we uncover the formation of this massive trench and the geologic forces at play. The record-breaking deep-sea dive. Here, so far from the Earth's surface, they took a moment to capture a self-portrait, commemorating their historic achievement. Yet, their mission was not just to reach this point, but to study and document the trench's unique features. Unfortunately, their submersible kicked up a cloud of fine sediment, making it nearly impossible to see anything. It felt like being inside a bowl of milk. Visibility was that poor. Realizing they could not complete their observational goals, they made the decision to head back to the surface. After a grueling 9-hour stint under the sea, the Trieste emerged off the coast of Guam on January 23, 1960. Walsh and Picard had not only survived, but also set a record for the deepest man to dive, a record that remains unbeaten. This dive was an incredible feat of human courage and technological prowess, marking a significant milestone in oceanic exploration. However, their successful dive left many questions about how such a massive trench had formed. If they couldn't find the answers deep within the trench itself, they'd need to look elsewhere. During the 1950s and 60s, under the guidance of Princeton's Harry Hess, a team of geologists began to gather and analyze sonar data from oceans around the world. They meticulously mapped the ocean floor, revealing that the Mariana Trench was part of an extensive network of underwater canyons that spanned the globe. Alongside this, they discovered something equally impressive: the East Pacific Ridge. This underwater mountain range, running parallel to the trench but on the opposite side of the Pacific, was part of a 40,000-mile-long chain of mountain ranges, making it the largest geological feature on the planet. This discovery was a major breakthrough. It suggested a possible link between the trench and the East Pacific Ridge, which needed further exploration. The answer came from an unexpected source. During the Cold War, the US had installed a vast network of underground seismometers to monitor atomic bomb tests around the globe. These instruments ended up detecting natural earthquakes as well. When these earthquake locations were mapped, geologists noticed they were concentrated along the ocean ridges and trenches. This pattern was revolutionary. It changed our understanding of the Earth completely. It showed that the movements causing these earthquakes were happening deep beneath the ridges and trenches. Thanks to this extensive network of seismometers, geologists could now precisely locate where these earthquakes were occurring, their depth, and their nature. This precise data provided crucial insights into the dynamics of plate tectonics, fundamentally altering our understanding of geological processes. A groundbreaking idea started to shift our understanding of the Earth. The surface of our planet is not one solid piece, but is instead made up of large sections called tectonic plates. These plates are always moving, sliding past each other, and sometimes colliding. This movement is what causes earthquakes. At the places where these plates meet, you'll find deep trenches and high ridges underwater. Two significant features are the East Pacific Ridge and the Mariana Trench, which sit on different sides of the Pacific Plate. The quest to understand how the Mariana Trench came about has been gathering more clues and information. The submarine named Trieste dove all the way to the trench's lowest point, proving it's the deepest spot on Earth. After this, sonar technology helped map the nearby East Pacific Ocean Ridge. Understanding the trench's origin meant studying what was happening at this ridge, which involved exploring the massive underwater mountains, some 8,000 feet beneath the ocean's surface. We know more about the Mariana Trench now that we've identified it along the western edge of the Pacific tectonic plate. Opposite this trench, on the other side of the plate, is the East Pacific Ocean Ridge. This ridge is part of a global chain of underwater mountains, the largest geological feature on our planet. Scientists suspected that this massive ridge could help explain how the trench was formed. They found a critical piece of evidence far away, where the ridge stretches under the middle of the Atlantic Ocean. Next, we find crucial clues that reveal how the Earth's crust is created and moves. Strange magnetic patterns under the sea. During the Cold War, the US Navy developed a way to find Soviet submarines using a tool called a magnetic anomaly detector. This tool could find metal submarine hulls deep in the ocean, but they discovered something unexpected. Along the ridge, there were strange lines of magnetic rocks, forming patterns that alternated between positive and negative. These were often described as looking like zebra stripes. Geologists know that Earth acts like a big magnet with a north and south pole, but these poles don't stay put. About every 300,000 years, the magnetic field flips completely. This means a compass that used to point north would start pointing south. This flipping of Earth's magnetic field is a fascinating topic and quite hard to explain. Scientists believe this is why we see those striped magnetic patterns on the ocean floor near the ridges. In the 1960s, it was discovered that molten rock, or magma, comes up from deep underground and creates these ridges in both the Atlantic and Pacific Oceans. When this magma comes up between the tectonic plates, it pushes the ocean floor up, forming these massive mid-ocean ridges. While the magma is still hot and liquid, its magnetic particles line up according to the Earth's magnetic field direction at the time. Once the magma cools, these particles get locked in place, effectively recording the position of the magnetic poles at the time the rock solidified. As more magma rises, it pushes the older crust away from the ridge, which also captures the reversals in Earth's magnetic field. This pattern of magnetic reversals is like a natural tape recorder that captures these shifts in magnetization. The pattern of magnetic stripes allows scientists to figure out how quickly the tectonic plates are moving apart. The zebra stripes confirm that the ocean floor in both the Atlantic and Pacific is spreading from these ridges at a rate of more than 2 inches a year. However, geologists needed more proof that magma was indeed shaping the ridge. If hot, molten rock was forming this giant mountain range in the Pacific, then the surrounding water should be warm. In 1977, a team of scientists set out to find out if this was true. Dudley Foster piloted these groundbreaking dives. It's always thrilling to be at the forefront of science, making new discoveries every time you go out to sea. Each trip brings a new set of scientists and new goals, and it's the excitement of exploration and finding new things that really makes the job exciting. For many weeks, a team of explorers searched the ocean's deep ridges without finding anything significant. Then, unexpectedly, they discovered something extraordinary. A towering rock spire releasing a stream of hot, toxic gases into the water. When they observed the surrounding water, it appeared to shimmer and bubble, much like when you heat water in a clear kettle. Curious, they measured the temperature and found it to be around 38 to 39 degrees Fahrenheit, remarkably warm for deep ocean water, which usually acts like a giant cooler, evening out the temperatures. This intriguing rock formation, known as a hydrothermal vent, was a critical find. It showed that heat from magma deep inside the Earth was seeping up to the ocean floor. However, this heat wasn't just spreading out evenly across the ridge, it was shooting up through these strange vents, creating pockets of unusually warm water. When discoveries like this happen, it's not always clear right away how important they are. It can take years to really understand the full significance of such a find, and this was definitely one of those moments. These hydrothermal vents turned out to be key in piecing together the bigger picture about the Mariana Trench. They provided proof that magma was continually pushing up new crust at the Pacific Ocean ridge. The discovery of magnetic zebra stripes, patterns of magnetic rocks on the sea floor, showed that the old crust was being pushed away from the ridge, moving toward the Mariana Trench on the other side of the Pacific Plate. This raised a big question for the scientists. If the ocean floor is continuously being made at the ridge and the Earth isn't expanding, then where's the old crust going? They realized that as new sea floor spreads out, an equal amount must be getting swallowed up somewhere else. and the big clue pointed towards the Mariana Trench. Is the Mariana Trench just an underwater canyon, or could it hide things that challenge our understanding of Earth? Share your thoughts, and don't forget to like and subscribe for more.